sort of review of sections 14.6 to 14.8. These whole sections, the 3 sections, are about what we call max-mean problem. Max-mean problems, or it is divided into 3 parts: local or relative, max, mean, what is local maximum, local minimum, and saddle points, by the way, as well. They are not maximum nor minimum, but they come with them because they satisfy the same condition they satisfy. When the first derivative vanish, all of the first derivative vanish, we have critical points, so they may give maximum points, minimum points, or maybe neither, and they are saddle points. And we'll revise the formulas for that. What else? Absolute maximum, absolute max, absolute mean. What else? Lagrange's method. Lagrange's method or Lagrange multiplier method to find max mean of f of xy or f of x, y, z, provided some additional condition. Provided an additional condition g of x, y equals 0. Which is a boundary. So we have some function we need to maximize or minimize, but with some other condition, extra condition. How to deal with these sort of problems? We have, as in calculus 1, we have what? Test of critical points of f of x and y. If f of x and y is differentiable, then the critical points are when f of x, fx equals 0 and fy equals 0. Or simply ممكن نقولها in one word, grad f is 0 vector. 0, 0. This is instead of these 2 equations. So we have these 2 equations to be satisfied to give critical points. What we get after solving these 2 equations, we solve this one, we get critical points. The critical points are satisfied as follows. Test number 1. Second, critical points, the critical points we get in 1, from 1 is fx equals 0, fy equals 0. So solving these 2 equations, we get some points. These are called critical points. So what about these critical points? We calculate, compute discriminant. What is discriminant? D given by fxx fyy minus fxy squared. You can write it this way to make it easy to memorize. The determinant fxx fyy here, to multiply them first, minus fxy repeated. Of course, if xy equals fyx if the function has continuous partial derivatives, as you know from section 3. So what we get? If we get d positive, if d is positive, then critical points, the critical point is points is local maximum or local minimum, which we'll know in another step. So now we distinguish between the saddle points and these critical points, which is maximum or minimum. When D is negative, the critical point or points is saddle point. At this critical point, F has a saddle point. Of course, you know what is saddle point? Saddle point means which a point at which from some view, some curve on the surface has a maximum point and another curve of the surface has a minimum point. This is the surface. I sent some picture of this, the potato chips you have. From some view, it is maximum. From some view, it is minimum. And so it is neither maximum nor minimum, what we call it saddle point. Means in Arabic, سرج, نقطة سرج الحصان يعني. Okay, so third step here to distinguish between, so if D is negative, the point is saddle point, we finish here. But if D is positive, we go to step 3. D is positive, so we go for FXX, sign of FXX, or FYY, but they have the same sign. Sign of FXX and or sign of FYY is the same. If this is positive, so the curve or the surface here is open upward, and here we have local minimum point. Because the positive second derivative test means the curve in calculus 1 or the surface here in calculus 3 is open upward, open up. Therefore, open up and contains some critical point. This critical point for sure is local minimum. What else? The other way as well. Fxx is less than 0, so this means the curve or the surface in calculus 3 is open down. Therefore, its critical point will be local maximum point. Z or f of x, y has a local maximum point at AB, the point AB. So take care of some here. If D is 0, the test fails.
Yes.
So what we have?
If
the discriminant is positive, if the discriminant is positive, we go for a third step, step 3, to distinguish between local maximum, local minimum. Step 2, to compute the discriminant to distinguish between saddle points and non-saddle points. Step 1, to find the critical points, equate the first derivatives with 0 and solve these two equations simultaneously to get the critical points. طيب هل الكريتيكال بوينتس هم the only possible points الكيرف or function, even the curve in calculus 1 can have max or mean? No, I said this many times in the lectures. The function may have no derivative at the point, like the modulus case, the absolute value function f of x, y. Modulus x is known. This is very famous example, which can be drawn like this V shape. This V shape. What happens? Here, y equals modulus x equals x here when x is bigger than or equal to 0, y equals negative x here when x is less than 0. Where is the maximum or minimum point? This function has no maximum, has no max, because it is extended up to infinity, no maximum point. But it has one minimum point when x is 0, y is 0. F has one local minimum point at 0, 0. الفانكشن دي عندها point which is local minimum at 0 0.
Okay.
بس هي is not differentiable. Why?
Why?
It is not differentiable at x equals 0. So the local minimum, local maximum can occur at critical points اللي هم الكاسبس، الكسرات اللي في المنحنى دي. When the curve عشان كده الكورنرز to be studied يا جماعه. الكورنرز may the function may have the max or mean at the corners of the bounded domain. We should study them separately. هنا يعني اللي عايز اقوله هنا انه مش لا it is not the only case to get maximum or minimum by the derivative. This happens when derivative exists, but when the derivative does not exist, like in this case, it may occur at the corners. Okay, يا جماعة? I'll show you some examples of this. This is an example from your web assign, and these are it's given like this. What it says as find the local maximum. The word local may be interchanged with the word relative. Local maximum, minimum values, and saddle points of the function given this way. This has no corners, this has no cusps. So this is always differentiable. So the only critical points can occur from the tests we mentioned now. يبقى امتى we have saddle points or local max or local mean when fx equals 0 and fy equals 0. This is the only way. Why? Because this is always differentiable. It is a polynomial function as you see. One of your colleagues give these answers. 4 here is right. It does not exist is right. He wrote the saddle point given this format. He wrote it 0 0. So it gave him false because he didn't write it in the given format. He needs to put it in this way: x, y, and z, the value of the function at the saddle point. When we have saddle points, Sama, what we'll get at the discriminant will give what?
Negative.
Yes. Got it, Assam? When the discriminant is negative, it is a saddle point.
هنا I have a question. هو لما تبقى 0 هكتب له test fails ولا هكتب له؟
Yes, the test fails. We can study it other way. Algebraically, maybe. I'll give you an example after this. Yes.
Okay.
It may fail, and we sometimes succeed algebraically to know what is going on. Okay. معايا يا عصام هنا. طيب الحل ده ازاي؟ How to solve this يا عصام? How to find this local max, local mean problems? So differentiate. Equate fx with 0, equate fy with 0. So what we get? Minus 4x cubed plus 4x. This is the fx, and fy will be
negative 2y.
Negative 2y, exactly. So equate this with 0. Critical points only at this. Critical points occur only at this case. ليه يا سما? Because you are asked sometimes to justify why critical points occur at this only, because this function is always differentiable. This function has derivative all the time at every x, y. So no cusps at the surface or the curve. So we equate these. So we get these two equations يا عصام. هو ده اللي انت بتسأل عليه.
Okay.
How to solve such equations? So let's solve them.
يعني ازاي بنجيب الكريتيكال بوينتس بتاعتها؟
طيب انت خلاص عملت fx و fy, equate them with 0. Yes. So you get two equations.
Okay.
ادي two equations اهم. You need to solve them. How to solve these two equations? What the first equation says minus 4x common factor times x squared minus 1 equals 0. And the second equation is negative 2y equals 0. So, as usual algebra, what happens? So this x equals 0 or x squared minus 1 equals 0. Minus 4x equals 0, it means x equals 0. X squared minus 1 equals 0 means x equals plus or minus 1.
Yes.
So we have 3 solutions for x. So 3 solutions for x. X equals 0, 1, negative 1. What's for y?
أظن بس 0.
Yes, sure. Y equals 0 only.
Okay.
Combine these solutions بقى. Points اللي عندنا ordered pairs x و y to combine to get the critical points.
Yes. يعني 0 0 1 0
0 1 و 0
negative 1 0.
negative 1 و 0. These are the critical points. This function, يسمى, this function has exactly 3 critical points.
طب قطر هو لو مثلا الواي عندها حاجة تانية، عندها critical point كمان هيكونوا 6 حاجات.
In all cases we combine them in all methods. So if
يعني
y is 4 يبقى عندي 6
عندهم 6 حاجات. اوكي.
مثلا بالظبط كده. دلوقتي ايه الخطوه الاولى دي؟ ستيب 1 يا عصام. ستيب 1 اهي.
اوكي.
solve fx equals 0 and fy equals 0 together. حليناهم simultaneously. Get the critical points. نعمل ايه بالcritical points؟ We go to step 2. This is step 1. Okay.
Okay.
Step 2, the discriminant, to distinguish between which of these points saddle and which is not saddle. So we go for step 2, the discriminant. To find the discriminant, remind me about the discriminant. D equals fxx fyy minus fxy squared.
اللي هو دي.
How to find D؟ ادي الفورمولا بتاعت الدي. So we have to prepare ourselves with we have to compute the second derivatives first. We have fx. From fx we find fxx minus 12x squared plus 4. Yes. Fy is minus 2y. Fyy is minus 2. So this is very easy. And clearly we have the second derivative negative now because it's minus 2 all the time. Okay. What is fxy? Fxy, you can find fxy from 2 ways. Even differentiate fx with respect to y or differentiate fy with respect to x. From here you get with respect to y, there is no y. So we get 0. Fxy is 0. From here fyx is as well 0. Got it, Hassan?
Yes.
Okay. Now substitute from fxx, fyy, multiply these together and subtract the square of xy to get what we call the discriminant.
Yes.
This is the way to memorize the discriminant easily. Put it in a determinant. We'll do some table to make it easy to see what is going on. So we multiply fxx fyy minus fxy squared. We get this minus 2 times this in bracket compound. This times this minus the square of this. The square of this is 0 here because it's already 0, but this is not the case all the time. So we get minus 2 times compound minus 12x squared plus 4. We can take some minus 4 common factor, minus 4 from here common factor times minus 2 outside, we get positive 8 times 3x squared minus 1. This is the discriminant for all points x. It does not depend on y at all. There is no y in it. Now we have the 3 critical points we already get from step 1.
Yes.
هنا these to be classify them into saddle, non-saddle points اللي هي الماكسيموم والمينيموم. اللوكال ماكس local mean. saddle point لما d is negative.
بس هنا مش هيكون
تعال نشوف. Let's go to calculate. This is we prepared our discriminant 8 times compound 3x squared minus 1. We have the critical points. We have 3 points. A 0 0, A10, B minus 10, O 00. These are the 3 points. You got them? Yes.
Yes.
Yes. Okay. This is, it's called them O, A, B. So we put them in the table, and this is the discriminant. Substitute at O with x equals 0. You get x equals 0. You get negative 8. Got it? Here is 0.
Okay.
So 8 times minus 1.
Yes.
Make it in detail, slowly.
This saddle point.
This, yes, we get the discriminant negative, so we get saddle point at O. The function has a saddle point at O00. The saddle point itself, with the format required in some web assigns, is 0, 0, and F00. So how to find the Z of the saddle point, the height of the function? You substitute for plug in x equals 0 and y equals 0 in the given function. For given function, originally this is the given function.
Okay.
Put x equals 0 and y equals 0, you get 3, only 3. Yes, this one. This is 0, 0, 0, so you get with z equals 3. So the right answer is, for saddle point, it is 0, 0, 3, at which the discriminant is negative. Okay. What else? At the point A10, so you substitute for x equals 1, you get positive. 3 minus 2 is positive, times 8 is positive. We don't care about the exact value. We care about the sign of the discriminant. So D here is positive. So this is not saddle point. Maybe maximum, maybe minimum. Again, the last critical point, DB, B. So substitute with x equal -1, we get the same result as in A, because -1 all squared is positive again. Positive 3 minus 1 is positive, times 8 is positive. So non-saddle point, it is local maximum or local minimum. Here we finished with the saddle points as well.
Yes.
The saddle point is, this surface has only one saddle point, 0, 0, 3. What about the local maximum and local minimum? Or maybe ask it about the absolute maximum or absolute minimum as well. Let's finish it all. How to do now for what else? Step 3. This is step 2. Step 2. Step 3. This is step 2, at which we distinguished the saddle points. Now, step 3, to distinguish the non-saddle points, which is maximum, which is minimum. How to know that? Again, we studied this. How to know, Sama? Remind us.
نشوف الساين بتاعت ال fxx بقى.
Yeah. بس بعد مين؟
بعد ما نجيب الديسكريمنت.
The discriminant was positive. After discriminant is positive, so check sign of fxx or fyy. أيهما أسهل؟ هما the same. They give the same sign. لو positive يبقى كده يبقى minimum. لو negative يبقى كده تبقى maximum. This is maximum point. Again, maximum ليه؟ عشان bigger than the values of the function around it in a disk around it. Here is local minimum ليه؟ Because the value of the function at it, A, B, f of A and B. Here the point A, B, f of A and B. So the value of f, A, B is bigger than the values around it in a small disk around it. Here, less than the value of the function at all the points in a small disk around it. If this disk does not exist, if some values of the function around it less than its value and some bigger than its value, it's neither local max, it's neither local mean, we call it saddle point. Now we make this table. Some people make it in one table. I do it in 2 steps for make it easy. Now we study the sign of fxx or fyy because they have the same sign. Why they have the same sign, Sama?
مش هم عشان نفس الحاجة صح؟
لا مش نفس الحاجة يا سما. بصي.
قصدي بيدوا نفس الساين.
Carefully because it may be justified in some question or so. Look at the discriminant formula, Sama. Do you see the pointer? Okay. It is
عشان هو
fxx times fyy, got it? Minus fxy square, yes? What do you
Yes.
know about this quantity?
إن هما
It's
they're
a
the
square
same.
quantity. This is a positive quantity, yes?
Yes.
So when D is positive, if the case is D positive, when D positive, this has to be what? If D is positive, this has to be
Greater.
bigger than this. Fxx, fyy must be bigger than fxy squared, which is positive. Therefore, fxx, fyy must be positive in this case.
Okay.
When some product is positive, either the two things are positive or the two things are negative together.
Yes.
For this, they have the same sign sum. In this case, in the case of positive discriminant. So now we have two critical points. The third is gone. The third is decided to be saddle point. This is done. 0 is done. Now we have A and B. So we go for the critical point A10, substitute for fxx or fyy. Fyy is easier here. Fyy is ready. Why? It is -2. Do you see, Sama? Save some time. If you substitute here, you will get negative sign for sure. But if you know it, take the easy way. So it's -2. Fyy is negative. Fy again at B is negative. So the function has local maximum at A and has again as well local maximum at B because the second derivative gives negative sign. So the curve or the surface, curve in calculus 1, surface in calculus 3 is open down and it has a local maximum point as you see here with the pointer. So fxy has two local maximum points at A equal 10 and B equal -10. It has no minimum points at all. If you need to write the point in the form, this as well, if we imitate the question in the web assign, the local maximum points here are 1, 0, and F10, which is 1, 0, and substitute for what you say, Aslam. And the other point is -1, 0, and F of -1, 0. What is F -1, 0? This is to substitute in the original function.
Yes.
This is the original function, Aslam. Put x equals 1 and y equals 0 to get what is the result. X is 1, so 3 minus 1 is 2, 2 plus 2 is 4, 4 minus 0, so it's 4.
يعني دي بنعملها في آخر حاجة خالص صح؟
Yes, if it is required here. If in absolute value, absolute max, absolute mean question, you have to tell this value is the absolute maximum.
Yes.
If it is more than this, I will compare the other one as well. So let us find F -1, 0. F -1, 0. So substitute, plug in x equals -1. So you get 3 minus 1 plus 2 minus 0 as well. 2 plus 2 is 4 again. So they give the same value because x square and x power 4. So they give the same value. Plus 1 minus 1, they give the same value. What is the same value? This is 4. So absolute maximum of f is what? Of f is 4. Yes, this is the absolute maximum. What is the absolute minimum? It has no minimum at all. It has no local minimum point at all. I need to remind you something from calculus 1, which is the extreme value theorem. What does it say, Sama?
يعني إن هو في restricted domain لازم عندنا value قصدي minimum و minimum.
Yes, if the the domain is closed and bounded domain, for closed and bounded domain, the function must attain its absolute max and absolute mean inside this closed and bounded domain. If it does not occur inside the domain, it may occur at the boundary. So we have to study the boundary. So what to say? Closed bounded domain in calculus 1 means a closed and bounded interval. For example, let's have this. Okay, let's have one more. Sin x, for example. What we have? From 0 is 0. At pi over 2, it's 1. And so on. It comes down and decreases and so on. I'll care about if f of x is sin x. It's the domain is whole of real numbers. But on 0 pi, this is a closed bounded domain. Because this is closed interval and bounded, it does not go to infinity. What is the maximum here?
Pi.
This is the pi over 2. This is x equals 0, x equals pi here. I'm looking at this part of the curve only. Okay. Absolute max of f. Absolute maximum of f here is on 0 pi is what? What is the maximum value of the function here? What's Sama?
Pi over 2, 1.
It's 1. The point is pi over 2 and 1. The absolute maximum value of the function is 1 at x equals pi over 2, exactly. The point itself is 1 and pi over 2. So the absolute maximum of the function in this interval occurs at it occurs at what? Local maximum point? Well, boundary point?
Local maximum?
Yes. This is the point. Pi over 2 and 1. Local maximum point. What about minimum? Do you see the minimum sum in this interval?
Yes.
Over this interval, where? What is the value?
Is 0 pi?
Yes, 0. Yes, at the point 0 and the pi, what is the value? The point here, pi, the value is 0, 0, 0.
Yes.
The value of the function is 0.
0.
At which x? At x equals 0 pi. Here, it's local maximum point. Here, is 0, 0 local minimum or pi local minimum? No, are not local minimum. But they are the corners, but they are the endpoints. They are at the endpoints or the corners of the domain. Endpoints of the 0 pi. Corners يا جماعة. Corners should be studied because the max or mean may occur at the corners of the closed bounded domain or the endpoints of the interval. If we continue and complete the graph, we can come to -1.
Yes.
Okay. This is closed and bounded interval. If we restricted the domain to closed bounded interval or domain, we get the maximum and the minimum may occur at points which are not local max or local mean. What they be? Why they may be? They may be at the endpoints of the interval, the corners of the domain. The same here. Look here at the, for example, the tan x. The tan, its domain is from negative pi over 2 to pi over 2. What do you see? The function has no maximum. Do you see Sama? Tan x has no maximum at all. It is always increasing because the domain is not closed. We have no corner. We have no endpoint here. The point pi over 2 is not included in the domain.
Yes.
The same is for negative pi over 2, the same situation. So some functions, Sama, some functions have no max, have no mean. Okay.
Yes.
These are examples of this. This is as well the non-function 1 over x, the inverse proportionality relation, y equals 1 over x. When x increases, y decreases, and go to the asymptotic line, the x-axis. And here we have a vertical asymptote. It will not pass it, and it will not touch it at all. So there is no maximum, there is no minimum of the function. What the corners? There is no corners, there is no bounds, there is no endpoints here. The domain is R. كل الR. R it's ما عدا except for the zero. Zero is not included in the domain, not to divide by zero. So we have very important theorem from calculus 1, and it is extended here in calculus 3. What is called stream value theorem. What is the working rule of it? The importance of it is to study the absolute maximum and minimum of a function in a restricted domain. We guarantee if this domain is closed and bounded, maybe a closed and bounded square, maybe closed and bounded, maybe closed and bounded square like this, maybe closed and bounded rectangle like this, maybe closed and bounded rhombus this way, maybe closed and bounded circle, maybe closed and bounded ellipse. This way, the boundary is included, may be part of it. Here we have what we say, this is the domain. The domain here is this boundary line and this boundary line 1, boundary line 2. If the function is restricted to such a closed and bounded domain, and we are asked to find its absolute max or absolute mean on this domain, we go for all the steps we have before. But we will add some other stage, which is to study this boundary line. This boundary line plays the role of the endpoints in calculus 1. We have in calculus 1 the endpoints here. The function may have its absolute maximum or absolute minimum at them. So we have to calculate f at these endpoints and to compare them with the value of the function at the local max and local mean to choose from them which is the greatest of the great and which is the lowest of the low to get the absolute max and absolute mean. But here the situation is more intricate. We have, it's not only boundary points, it's not only endpoints, we have boundary line 1, all of this curve, we have to study the points on this curve. The function may have its absolute max or mean on it. Boundary line 2 the same, and the corners as well should be studied. These corners, corner 1, corner 2. Here the same. Here no corners, but the boundary line. Only one boundary line. اللي هو ده. Given some equations will be given in the problem. One boundary line. Here we have 4 corners. Boundary line 1, boundary line 2, boundary line 3, boundary line 4, corner 1, and so on. 2, 3, corner 4. الدومين هنا this closed and bounded domain in R2. Here, for example, this may be D, xy, such that x from 1 to 3, y from 0 to 2, say. So this is ادي x ب 1 up to 3 وال y from 0 up to 2. This is the region and so on. Here maybe this way, different. He will give you the description of the domain. Here, for example, this is from negative 1, 1 cross negative 1, 1. May be written this way or that way. This can be described again in set theoretic notation xy such that x from negative 1 to 1, y from negative 1 to 1. So you sketch this restricted domain and determine the local maximum, local max mean points, critical points as usual, and add the study of boundary lines one by one. You study one boundary line by one boundary line. Finish, you have to study what else? Real boundary line, the corners. Corners. 1, 2, 3, 4. Here نفس الشيء. Corners, we may get some triangle. What else? Boundary. We have here to study this as well. The domain. We will come to them one by one. Here, for example, we'll give you the equation of this line, maybe y equals 3 minus 2x, means here 0, 3. When y equals 0, x equals 3 over 2, 1.50, and so on. This is the boundary line 1, boundary line 2, boundary line 3. And these are the corners. Corner, corner, corner. What to do with these corners? We determine their coordinates and the value of the function at them and add them to the table of the value function values at the local max, local mean points, and the critical points you get at the boundary lines. Collect all of these data and compare them to get which is the absolute max and which is the absolute mean. This equation is x square equals, for example, a square circle. This is the whole circle. We have no corners here, Assam. If it is the whole circle, it has no corners. So only one boundary line. Only one boundary line, اللي هو الكيرف يعني, curve of the circle. We can study it using Lagrange. We can study it using Lagrange method, which is section 8. Lagrange's method, section 14.8, the last one. Even here for the ellipse, we can study it using the same thing, same method. Even it is part of a curve, we can study it as well using Lagrange. But we need to choose if the point are there in this boundary, on this boundary line or not. So we study the whole ellipse or the whole circle, but study, choose from them the ones satisfying our additional condition. Okay. Okay, let's show you some example. This is some sort of question in this way, yes. Okay. Find the absolute max, absolute mean on the restricted domain. This is the domain given SAMA. How to read the domain? This is very important to be sketched correctly. Y equal to 0 means what, Yassam? We are concerned with the point above the x-axis or below the x-axis?
لا فوق.
فوق, تمام. And x less than or equal to 2. To the right of x equals 2 or to the left of x equals 2?
left.
كويس. والتالت y equals 2x ده an oblique line, slant line, inclined, مايل يعني. مش horizontal, not horizontal nor vertical. So we draw all of these 3 lines and determine the region. So let's go and draw them carefully. y bigger than or equal to 0, and the x is what? Less than or equal to 2, and y is less than or equal to 2x. y less than or x less than. اوكي مظبوط. خدوا بالكم be careful. الكلوزد اند باوندد دومين هو ده، ان هو less than or equal، الايكوال ساين معايا، فالباوندري لاين معايا. مفهوم يا جماعه؟ هو ده اللي يخليني I have a guarantee to get the absolute max and the absolute mean inside this restricted closed and bounded domain. We have a guarantee by this extreme value theorem from calculus 1 and its extension in calculus 3. So مشكلتنا دلوقتي ايه يا عصام؟ Let's draw this region correctly. You have many points for this, at least 1 point. يلا يا عصام.
y increasing يعني هتبقى فوق الاكس اكسس.
This is the x, this is the y. What about y equals to x? Y equals to x. How to draw such a line? Y equals to x. Put x equals 0. What you get? 0, 0. 2 times 0 is 0. 0. 1. When x equals 1, y, what is y?
2.
Yes. So we are here. 0, 0. 1, 2. And 2 gives what?
And 2 is 4.
Yes, right. So let's move this to match our line. This is 1 and 2. And this is 2 and 4. Where is x equals to? When you have an x equals constant or y equals constant, you have a vertical or horizontal line.
Okay.
X equals 2 is, where is x equals 2? Here x equals 2. X equals 2, and you have this vertical line here.
Okay.
This vertical line is, its equation is x equals 2. All of the points on these lines, on this line, have coordinate x equals 2. So when x is less than, I don't need x equals 2, I need x less than or equal to 2. So x equals 2 is the boundary. X equals 2 is the boundary. What else? Less than 2 is to the left or to the right?
The left.
Yes, here x is less than 2, exactly, is 1. X equals 1, x equals 0. So x less than 2 is to the left of this line. What else? Where is y equals 0, Sama? Y equals 0 is?
And the x-axis.
What I said, y equals 0 is the x-axis, right? So this is x equals 2. This is vertical line, x equals 2. Y equals 0, this is the x-axis. Because all of the points on the x-axis have y coordinate 0. Got it? Hassan? Y equals 0 is the x-axis. X equals 0 is the y-axis. I don't need it. So let's combine all of these conditions together, Hassan. What we need is to solve all of these inequalities together. What is inequalities? We need to satisfy all of them in the same time. We have many things to do with simultaneous solution in this exam. So we sketched the line x equals 2, this vertical line. I use the pointer, this x equals 2, this vertical line is x equals 2. I need the region to the left of it. Here, this one. I drew y equals 0. It is drawn already, the x-axis. I need y bigger than 0. Equal 0 or bigger than 0? Up there or down?
Up.
Up, yeah, okay. So we have these points as well. The third one, y equals to x. This oblique line, this inclined line, y equals to x. We drew 2 points and connected them you need y less than 2x, less than or equal to 2x, equals on the line. Less than 2x, where is the y? Less than 2x. Below the line or above the line?
No, below.
How to know? How to know? I tell you how to do. This is y x equals 1, and here is y, 1 and 1. Is the y less than 2x? Yes. Y is 1 and 2x is 2. Yes, y, 1, 1. Make this true, because 1, the y, less than 2 times 1. Right. So we need the y is less than 2x. So we need the points below this line, down this line. So where is the region? Assam, satisfying all of these three conditions. Y bigger than or equal to 0, this red part.
يبقى الاكسس من 0 ل 2 والواي من 0 ل 4.
Yes.
صح؟
صح.
والواي
the region here is the main. You need to tell me which region, which form. This triangle or the one above here, this triangle مثلا.
لا اللي تحت.
اللي تحت. ليه؟ Because we need y less than 2x, not y bigger than 2x. We will come to this triangle. If this was bigger than or equal to, we come to this part, not this one, and solve another problem. So it's very important to draw it carefully. Got it?
Yes.
Okay. This is 1 and 2, this point. So how did we sketch this and choose the region? X less than or equal to 2, this black dashed here, going this way. All of the left part of this line. Y bigger than or equal to 0, we come to this. What is bigger than y equal to 0? All of this. What else? The green, y less than 2x, we come to this region less than this line. So what we are looking for, Sama, now, the region satisfying all of these three conditions in the same time. Satisfying the blue, satisfying the red, satisfying the green. Where is that, Assam?
اللي هو التراينجل ده.
أيوة, exactly. The triangle A, B, C. Or A, B, O, because O is the origin. What are the corners here? This is 2 and 4. Why is this important? These corners, the function may attain its absolute maximum or absolute minimum at some of them or not. We are not sure. We have no guarantee that they occur at these corners, but it may. So this is 2 and 0. O is 0, 0 as seen. So we have the three corners. We have this boundary line. We have this interior region. We find stage 1, we find the local max, local mean of the function f as usual, but reject any point outside this restricted domain, because this is an extra condition. Any point outside this interior region, this triangle, is rejected. If it is inside this region or on the boundary of this region, we take it. It is a candidate for the absolute max, absolute mean situation we have to deal with. Very important. It's very important to draw it carefully, to draw these lines and determine these corners and study as usual. Okay.
طب ازاي يا دكتور بنجيب الابسولوت ماكسيمم مينيمم؟
Yes, let's go to the problem. Okay, find the absolute max or the absolute mean on the restricted domain. This domain will be described, maybe a circle, ellipse, triangle, rectangle, and described set theoretic notation. You should draw this carefully, very carefully, and determine the corners. This is the function. How to find the absolute max and the mean, Assam? Step 1, as in the previous example.
Yes.
Find the critical points in the whole domain and reject the points outside this domain. If x is bigger than 2, reject it. If y less than y is negative, rejected. If y is bigger than 2x, rejected. So how to do it? Differentiate, we get 4x minus 2y. We differentiate with respect to x, easy. This is negative 2y, here gives negative 2. This one equation as sum. This is fx. What is fy as sum?
2y
minus
2x.
X. What we need to do now to solve these two equations. Solve for the critical points. We solve what we solve. You see what I wrote here? Fx and fy equal 0. Equate fx with 0, equate fy with 0, and solve them together. So 4x minus 2y, this, equate it with 0, and this, we need to solve them together. This is different from the example before. So how to do it? Simplify, divide by 2. You get 2x minus y equals 1. Here we get y minus x equals 0. So let's take them and try to solve them together.
انا كنت بقول على كده يا دكتور لو لقينا
Yes.
مثلا في اكس فيها اكس وواي.
Okay. Solve these two equations together, Assam. How to solve them? This is very easy. Substitute, for example. Here, they have x and y together. So we can substitute. The easiest thing is to substitute. This says y equals x. Number 1, number 2. 2 is easier. In 2, y equals x. Substitute into 1. How solve these such two equations, Yasan? Substitution. The substitution method is the best method.
Okay.
It always works. Okay, so substitute for y equals x here into 1 to get 2x minus y is x is 1. Therefore, 2x minus x is x, so x equals 1. We have one solution. Substitute again into 2. So y equals x equals 1. So we have, the point is, x equals 1, you have to write x first.
Okay.
So we have one critical point. Check هل هي في الباوندري هل هي sorry in this restricted domain, in the domain. If it is in the domain, we take it. If it is outside of the domain, we reject it. Okay, so we get one critical point, 1, 1. It is in the domain. It is in the domain. What does it mean to be in the domain? انت ما شفتش هي local max ولا local mean ولا saddle. I don't care because he didn't ask me. It is critical, so I'll take it into account when we finish our study.
دي صح؟
لا مش هنجيب دي. بص هنا الكويشن يا عصام سألك على اللوكال ماكس واللوكال مين والسادل بوينت.
لا.
خلاص ما نجيبهاش. We don't go for the discriminant and this stuff. It is restricted domain. Assam, it is restricted domain. It's a triangle or a square or a rectangle or rhombus or whatever.
Okay.
So we care about the critical points. It's a candidate anyway. If we are asked to distinguish whether it is saddle point or not, we will go for this. Otherwise, we'll leave this part. Now, step 2, go for the restricted domain. This is the careful drawing of this closed and bounded region. Why I stress the word closed and bounded description of the domain? Because we have a theorem about this domain. This sort of domain, we have a theorem, the extreme value theorem, which guarantees that the function has, or it must attain its absolute maximum or absolute minimum inside or on the boundary of this domain. If the domain was not closed or not bounded, we have no guarantee to have a maximum or minimum at all, as we have in the examples. So now we have what to study, Sama? We need to study boundary 1, boundary line A, at which y equals 0, boundary line B, at which x equals 2, boundary line C at which y equals to x. We know this from where these equations given, they are given in the description of the domain. We need to study each line of these. How to study them? As follows. We study fxy at the boundary lines. How to study the boundary line? We take its equation, its bounds, and study the original function. Substitute with the conditions of this this is the given function, and this is the boundary line 1 or boundary line E. What is the equation of this boundary line? Is y equals 0 and x varies from 0 up to 2, closed bounded interval. So what to substitute for this? Substitute for y equals 0. So x is the same and y is equal to 0. So plug in y equals 0 to get 2x squared plus 0 minus 0 minus 2x. I put y equals 0. So I get 2x squared minus 2x, which is a function of x only. What I'm looking for is the critical points, the maximum, the minimum of the original function. The original function becomes h of x at this boundary line. So can you tell me whether h has critical point, or what is the maximum point or minimum point of h? H of x equals 2x squared minus 2x. Where are the critical points of h, يا سما؟
نجيب الديريفيتيف عند 0.
نجيب الديريفيتيف وايكويتد with 0. Yes. h prime of x 4x minus 2. When this derivative equals 0, what we get? 4x minus 2 equals 0. Solve it, Osam, to get x equals half.
Yes, okay.
Is x equals half here in this domain, in this interval?
Yes.
Yes, satisfies inside on boundary line A. Yes, we take it. So this is a candidate. This may be the point at which the function attains the maximum or minimum.
Okay.
Got it?
Yes.
Okay. So save this point. What else? No more points. This is the only solution. The boundary will be studied at the end. So the same for the other boundary lines. نفس الكلام will be repeated twice and third time. This is the point. This is the point. X equals half, and what is this boundary line A? Y equals 0. This is on the x-axis. The second boundary line, Assam. Where is the second boundary line? Boundary line B. This is, I'll use the pointer, you see it. Will the boundary line x equals 2?
2?
Equals 2, yes.
Okay.
Less than 2 is the interior domain, is the interior region. We got already 1 for the interior domain from the first study. When we equate fx equals 0 and fy equals 0, we get 1 point, which is 1 and 1. All of this interior domain has only one critical point, 1 and 1, which is a candidate for the absolute max and mean. No more inside. If there is one more inside this domain, it would come when we equated the fx equals 0 and fy equals 0. Now we are on the boundary line of this domain. We finished with the domain, the boundary line A at y equals 0. We get one critical point here at half. The second boundary line. Yes, tell me, Assam.
اللي هو x equal 2.
X equal 2. Yes, we take it the same. We take the function again. Oh يا Assam. ادي الباوندري لاين بي الايكويشن بتاعته x equals 2. الواي varies from 0 to 4. نعمل ايه؟ ادي الاوريجينال فانكشن اهي. الاوريجينال فانكشن. Yes. Substitute for x equals 2. Put x equals 2 instead of x. Plug in x equals 2. What you get? 2 times 2 square plus y square minus 2 times x is 2. Y stays 2. minus 2x, 2 times 2 is 4. So simplify this and find its critical point. What you get? 8, 2 times 4, 8, plus y square minus 4y minus 4. Arrange it, y square minus 4y plus 4. Where are the critical points of this function? يبقى الفانكشن f of x and y on this boundary line, on boundary line B becomes what? Becomes g of y. Becomes a new function. The previous boundary line was h of x. Now we have g of y. How to find its critical point? Differentiate and equate with 0. So g of y equals y square minus 4y plus 4. We can do it algebraically by completing the square without calculus. It is y minus 2 all square. But we go with usual calculus. G dash y equals to y minus 4. And g prime y equals 0 if and only if what? 2y minus 4 equals 0. Therefore, y equals 2. This is it on the domain? Look carefully, Hassan. Is
Yes,
yes, inside the domain. Taken or rejected? Taken. In the domain. Y bigger than 0, less than 4, inclusive for the endpoints to be closed domain. So it is critical point. What to do else? We go for f of x, y on the boundary line C. Substitute for y, put 2x, and you get a function of x. This is, so plug in, substitute 2x instead of y, you get this, simplify it, find its critical point, check half in the domain 0 and 2. Yes, so x equals half and y equals 1 on this boundary line. So we get 3 critical points. So what we have done here, Assam, on boundary line A, we get critical point. At boundary line B, we get another critical point. On boundary line C, we get a third critical point. We add all of these new critical points on the boundary to the critical point inside the interior region. Okay. Add to all of these the corners and compute the function value at all of these candidates for the absolute max and absolute minimum problem. What we have, this is what you have said before, Assam. This is the function, Assam. This is the original function. We find its value at the critical point we get. Critical point, interior. Interior critical point. We found a critical point at the boundary line A. We found a critical point at boundary line B. We found a third critical point at boundary line C. We have 3 corners. O and A and B, if we call them this way. We have the corner 2, 0, we have the corner 2, 4. You are given this function and you are asked to find the absolute max, absolute mean of it, provided that the points are in this domain, this closed and bounded domain. So you go for local max, local mean. Stage 1, you find the critical points as usual, but provided that they have to be inside this region. If they are outside this region, reject them. Save the critical points found as usual, but inside this region, and work for the boundary line. Boundary line, this boundary line 2, boundary line 3. Maybe 4 boundary lines if we have a square or rectangle or rhombus or this sort of stuff. Compare the value of the function, this function. Compare its values at the critical point from stage 1, interior, and stage 2, the boundary lines, and the corner of the region, the cusps of the domain. And arrange this table, this is step 3 or stage 3, form the table of all critical points, all the candidates for absolute max and mean. This is a function. This is a given function originally. Evaluate it at each of these points using your calculator easily. Use the calc button. It will make your life easy. And you compare these values. So you get the smallest value. The lowest of the low here is -1. This is the absolute minimum of the given function. It occurs at 1, 1.
وانا لازم اجيب الديسكريمنت وكده ولا؟
No, he didn't ask you about saddle points or distinction or to distinguish between the critical points, so we skip this part.
ممكن تكون الفور دي سادل بوينت مش ماكسيمم صح؟
No, cannot be. Saddle point cannot be absolute maximum or even cannot be even local maximum. هي ليه saddle point يا محمود؟ قال ان هي maximum من ناحيه ومينيمم من ناحيه.
تمام.
فلما هي maximum من ناحيه يبقى ما هياش minimum. ومينيمم من ناحيه يبقى ما هياش ماكسيمم. فالسادل بوينت cannot be this sort of point you are talking about. حتى لو هي كانت النقطه الكريتيكال دي كانت سادل بوينت وانت ما عرفتش انها سادل بوينت، مش هيحصل اي حاجه، مش هنختارها في دول، مش هتبان. compare the values cannot be. The extreme value theorem says or guarantees that the function defined on a closed bounded interval in calculus 1 has absolute maximum or minimum inside the interval or on the endpoints. The maximum and minimum may occur at the endpoints of the interval in calculus 1 and can occur as well in the boundary line of calculus 3. This is the extreme value theorem. This is an important theorem.
طب والكورنرز؟
والكورنرز
يعني بايفالويت على عند الكورنرز وعند اللاينز.
We studied the interior by the general study. We studied the boundary line one by one, and we will add the corners to the table. These are the corners: 0, 0. The second corner of the triangle is 2, 0. This one, 2, 0. This is the corner B, and the corner A, 2, 4. Evaluate the function value at all of these points. When we finish the evaluation of the function values at all of these points, we choose the greatest of these, the greatest of all these values, which is 4 here in this example. This is the absolute maximum of this function. And it occurs at 2 points, 2, 0 and 2, 4. So this function attains its absolute maximum value 4 at 2 points, 2, 0, 2, 4. The name for these 2 points in space is absolute maximum points 2, 4, 4 and 2, 0, 4. Because some questions on the WebAssign ask you to write the point in details in X, Y, Z coordinates. And what is the smallest value of this table? The function values of this table is -1, which occurs at 1, 1. So the absolute minimum point occurs at 1, 1. The absolute minimum value of the function is -1. So the absolute minimum point is 1, 1, and the Z value is -1. This is the end.